Classic ASP is a technology that Microsoft created in order to ease the development of interactive web pages. You can write code that is interspersed with HTML in order to create dynamic web pages. The problem is that when the web was originally created, it was a series of static pages that were linked together. There was some interaction in that users would click on the links, but the pages themselves really didn't do all that much. So as the web continued to evolve, developers had to come up with ways of making web pages more interactive. This is necessary to enable a lot of the sort of applications that we take for granted today. For example, going to Amazon.com, adding books to your shopping cart, and then checking out. But in the early days, things like HTML forms were quite innovative, where you could fill in text boxes and actually send information to the website. So there were various technologies that enabled this. One of the earliest ones was CGI scripts, or Common Gateway Interface. These are essentially a set of scripts that run behind the web page on the server to create dynamic HTML. So these various technologies that created early interactive web pages intercepted web requests and ran programs that created and returned custom web pages, doing dynamic HTML generation. And it was usually based on data that was read from a database. So after a couple of false starts, Microsoft introduced ASP, or Active Server Pages, into the fray of interactive web development technologies. And so this became their basic web development technology that early Windows web applications were built upon. So let's take a look at a classic ASP page. Here's a sample ASP application running in Internet Explorer. I've previously configured this application in order to set up a virtual directory within IIS called Introduction. And then I loaded the page. It's a pretty simple page. It hit the database in order to populate this list of categories from the Northwind database. And when I select one, I can show the products that are contained within that product category. The page request and the pages they point to are handled within the ASP runtime environment. These requests and the pages they point to are handled within the ASP runtime environment. This environment supports pages that contain code and special script blocks within script elements that include the attribute run at server. So that script within the page performs whatever processing tasks are necessary on the server in order to generate the page. So let's take a look at the page source. I'll come back over to Visual Studio. Nice thing about Visual Studio is that even though I've loaded up an ASP page, it still gives me a little bit of highlighting so I can edit these pages easily. In this case, the server-side scripting code that I'm using is VBScript. You could use JavaScript as well, but VBScript seems to be the language of choice for ASP pages. I have an option explicit, and then I have some HTML elements. So I have the HTML and the head and the body and the form element. All right, so that's typical HTML. But then embedded within the page itself is some scripting code. Here is one of those special server-side scripting tags that indicates that what follows is server-side script code. This is the code that automatically runs every time the page is requested. So I declare some variables. I create an object. This is an ADODB object, which is a COM-based object. It's a precursor to ADO.NET within the .NET framework. And then I open up a connection using a connection string. And this is just going against the local instance of SQL Express and connecting to the Northwind database. Then I can use the ADO command object, pass it a select statement, and then call the execute method on that command object and get a record set. At this point, I'm all set to start populating the page with the list of categories from the database. Before we look at the rest of the code, let's talk a little bit about the objects that are available within ASP. Because as we're going to find, a lot of the same objects are available within ASP.NET applications. The code that we just looked at uses the createObject method in order to instantiate a COM object in order to read the database. It's part of the old ADO data access technology. So in addition to providing a script execution engine, ASP also provides a set of 6 objects, including that server object, that facilitates the development of web applications. The request object is used to read data that is packaged inside the HTTP request for the page. It essentially looks at the headers that are passed from the browser to the server to get various kinds of information, and you can access that information via the request object. The response object lets you modify the set of HTTP headers that are sent back to the client as part of the response when you send the web page back down. The session object is created when the first request from a particular client is processed, and then it stays in scope as long as the user continues to make requests or the session timeout period has expired. And typically that's about 20 minutes on most web servers. And what it does is it allows you to save various bits of information about the session, about this particular user, and his or her interaction with the web page. The application object is similar to the session object, except that the variables that you store in the application object apply to all sessions within this particular application. So it's shared across all client requests over the lifetime of the application. And you can write some code that executes anytime the application starts or it terminates, such as when you restart IIS or restart the server. The object context object is a little bit esoteric. What it does is it allows you to commit or abort transactions that are managed by the Microsoft Transaction Server, MTS, or sometimes called COM+. We're not really going to get into that in this course because we're not going to be looking at those kinds of distributed transactions. And then finally there's that server object, which provides a bunch of generic utility methods for doing things like creating COM objects. And you can also do things like encode data as HTML or URL strings within the HTML that is sent back to the browser. And they can also do things like find the actual file locations that correspond to virtual paths. So it's a very useful utility method. So let's take a look at more of the features within that classic ASP page. The next snippet of code begins processing the rows within that record set. So we have a do until loop that processes the records until we reach the EOF, or the end of file marker, for that record set. And then here's where we use the ASP response object, and specifically the write method, in order to dynamically generate HTML that is sent down to the browser. Now, there really isn't any support within ASP for generating well-formed HTML. So we have to create some strings and concatenate them together in order to generate the HTML that's sent down to the browser. So we have the option opening tag, setting the value. We want to use the value of the category ID, and all of that concatenated together produces a single HTML element. One of the things you'll spend a lot of time doing when you develop web applications is working with postbacks. A postback happens when a web page sends data back to itself on the server. So rather than having a link on a page that goes to another page on the server, this is now going to send data to the same page that the user is currently looking at. Typically what you're going to do here is do something with that data to customize the page. The end result of working with the data that the user sends may be to change the appearance of the page. And in fact, that's what the sample page does. The user is selecting a category, and now we're going to populate the rest of the page with the products in that category. So we're dynamically changing the appearance of that page. So the whole idea here is that when the postback occurs, some sort of dynamic code is going to execute on the server that customizes what the user then sees. Now, in the example page on the products, it's going to reload that exact same page and display the products within that category. Now, the reason this occurs is that the page's address appears in the action attribute of the form element. And this is what it looks like in the sample page. So the action attribute has the products-asp.asp page within the form element, and that creates a postback. If the action element had another page's address or name there, then it would not be a postback. So when the user clicks on the button, a postback occurs, and the drop-down list is populated all over again. But we want the users to see the category when they get the new page, which also shows them the products in the category. So we have to do different things based on whether or not it's a postback. So let's take a look at how this works. The next line of code here shows how you have to customize ASP yourself in order to handle the situation where the page posts back to itself. In this case, we're going to check to see whether the value returned by the request object, the category variable, matches the current row that we're processing. If it does match, then we're going to add the selected attribute to the option element. The reason we're doing this is because we want to make sure that the page, when it's sent to the server and then returned to the client, reflects the same category selection. If we didn't do this, then every time the user posted back to the server, they would lose the current selection in that drop-down list box for the categories. All right, if it's not a postback, in other words, if the page is being requested for the first time, then we just go ahead and close out that option element. Then the rest of the loop finishes out the option element by writing the category name between the open and closing tags, and then closes out the tag, and then moves on to the next row. And then the loop repeats until we run out of category names. The code then finishes up by closing the record set, and then setting the record set and the command objects to nothing. Then the code moves on to supply the closing select statement. And that ends the rendering of the drop-down list box. And then it renders the submit button. Now, the rest of the page runs only when it is a postback, after the user selects a category. Because when the users first call up the page, only the drop-down box and the button should appear. Once they pick a category and click the button, they receive a list of all the products in that category, formatted as an HTML table. So ASP accomplishes this by alternating between sections of code and sections of literal HTML, building the table dynamically. For this particular page, we can discover whether or not this is a postback by checking the length of what is returned by that category selection. If it's greater than 0, it's a postback because the user has selected something from that drop-down list. So now we need to create another record set object. We'll open up a record set by providing a select statement, which sets us up to get the data for the selected product groups from the database. All right, at this point, we've set up the record set and it's ready to read data. We have to supply a header for the table, and this provides the static HTML for that. This is not included within a script block tag, so this HTML is going to be sent down to the client intact. For the rest of the table, we need to loop through the record set and create a table row element that is populated with the data from the record set. So we contain this literal HTML with a little bit of embedded code between script blocks. Okay, so we start the row, we start the cell, and then we read the value of the product ID. We close out that cell, open up another cell, and write the product name, and do the same for the units in stock. Then we move to the next record, loop around, and we continue to do this loop until we run out of data. And then we close out the table, we shut down the connection, and then we supply the rest of the static HTML in order to close out the form, body, and HTML elements. So you can really see how you have to intersperse server-side code amongst the HTML in order to generate an ASP page. Now I'll go back over to the browser that's still running the application and has a list of the dairy products. I'll view the source behind the page, and you can see that ASP has dynamically generated a form with a table that contains all of the products within the dairy products category in the Northwind database. So this is the end result of all that code and HTML that's contained within the ASP page. In this example, the HTML delivered to the client is very simple, but the ASP application can embed styles, graphics, hidden form controls, and even client-side script to create complex and full-featured web pages. Now, as useful and as successful as ASP is, it has several important limitations that were a large part of the motivation for Microsoft to develop ASP.NET. The first problem is that ASP uses interpreted and loosely typed code. So what that means is that the script execution engine that ASP uses interprets code line by line every single time the page is called. There's no efficiency for when you reload a page, and that just hurts performance. Another kind of related problem is that scripting uses loosely typed variables that are typed as variants, which means that they can contain any kind of data. And those are bound to a particular type only when the code executes. This causes all kinds of problems because it's much easier to write buggy code because you don't have the type checking that is an inherent part of most modern development languages. So both of these factors impede performance, and the late binding of types makes it harder to catch errors when you write code. And you don't have IntelliSense, that wonderful feature within Visual Studio that makes it easy to remember all of the different options and features of a particular object. Now, to overcome this limitation, a lot of developers would use COM objects. In fact, I'm sorry to say that I'm still maintaining an ASP application that heavily uses COM objects, and it causes no end of problems. The biggest problem is that anytime that we have to update the COM objects, we have to shut down IIS. Because once IIS loads a COM object, it keeps it in memory for the duration of any kind of session. So it's very difficult to maintain that website. A second problem is that ASP makes collaboration very difficult. As you saw, there's a lot of interspersing of VB script or JavaScript, whichever language you're using, with the HTML code. So if you have a situation where you have a designer that is tasked with making your website beautiful and with all the nice graphics and so forth, that person can't easily work with the developers because the developers have to come in and intersperse all of this scripting code amongst all of the HTML. There isn't a separation of the files, a separation of the tasks. I would go so far as to say that ASP encourages bad programming practice because you just have to mix the HTML with the scripting code. ASP also has very limited development and debugging tools. Microsoft Visual InterDev, well, let's just say that it was a nice effort. It certainly helped with ASP development, but it fell far short in providing a full, rich graphical development environment. Now, granted, InterDev came along several years ago, and tool technology has advanced quite a bit. But ASP development was just never as easy to use or as readily accepted as other Microsoft Windows development technologies. And so a lot of ASP developers just rely on Notepad. It's just a lot easier and the tool just doesn't get in your way. A large part of the problem is that the typical ASP page, like most web application pages, combines elements from a variety of different technologies, including VBScript, JavaScript, cascading style sheets, dynamic HTML, ADO, XML, XML style sheets. And handling all these technologies together in a development tool is very difficult, particularly when all of the elements have to be located within a single page, a single physical code module, ASP page. And then debugging was a nightmare. Debugging is just unavoidable with any kind of code. And the debugging tools for ASP are pretty minimal. So if you've done any kind of ASP development, you know well the pain of embedding all kinds of temporary response.write statements into your code and then having to remember to remove those before you deployed it. It's just a very messy situation, and to this day, the ASP debugging tools just are not there, just not very full-featured. One of the big problems with ASP comes with when the application gets so big and is so heavily used that you have to distribute it across multiple servers. ASP creates a server affinity for session state that is very difficult to get around. What the problem is that when a user makes his or her initial request to the server, the session state is created on that server that the request is first handled by. If you have a web farm, the second request from the user when they post back to the page may be handled by another server. But the problem is that that user's session state is on the first server, and there wasn't an easy way to share the session state between those machines. So that actually created a very rich opportunity for third-party products when ASP first came out. And the problem, of course, is that ASP was created before the web farm architecture was very prevalent with web applications. So you just had to work around that in some way because there was nothing within ASP itself that overcame that server affinity problem. Another problem with ASP is that it uses some rather obscure configuration settings. They're stored within the IIS metabase, which is a binary store. It's essentially a registry-like repository built into IIS, and developers find the structure of the metabase hard to understand and hard to navigate. And in addition, it was very hard to migrate those settings from one server to another. Yet another problem is that even though postbacks are a very common part of web application development, you had to write code for the postbacks in every page. And we saw that in the sample ASP page, where you had to actually write the code in order to repopulate the controls upon a postback. Otherwise, those controls would be empty when the user posts back to the page. Another problem is multi-browser support. If you were writing an intranet application, then very often you might have control over the browsers that people use. So within a corporate environment, you might mandate Internet Explorer or Safari or Firefox or whatever. But on a public internet site, you just couldn't count on that. And back in the days when the browser wars had not been successfully won by Internet Explorer, you couldn't count on users coming at your website with a particular browser. And unfortunately, the standards were looser, and it was very difficult to develop sites that were browser agnostic. And ASP provided absolutely no help with that problem. The end result is that ASP caused and fueled an explosion of web development on Windows, but it had a lot of problems that developers constantly had to battle. So ASP.NET came to the rescue. ASP.NET was largely developed as a response to these problems in ASP. Developers were just having too many problems creating large, scalable applications. Now, even though the .NET framework has grown to encompass a lot of other features, ASP.NET was really the core impetus behind the original development at Microsoft. Microsoft was just going for a new way of efficiently building modern and scalable web applications. So it should come as no surprise that ASP.NET very nicely solves most of the problems with ASP. So ASP.NET provides compiled and maintainable code. It uses the Common Language Runtime, or CLR, rather than a scripting engine. So on the server, you're actually running compiled code that can run as fast as any code can run. You have the full power of the .NET languages, the full power of the .NET framework, and code can be compiled just in time so that it's customized for the particular browser that is accessing the site. ASP.NET also takes advantage of the nice object-oriented programming that is available as part of the .NET framework. Every page that you develop and that you're going to see throughout this course is derived from a generic system.web.ui.page class. And that page class provides most of the infrastructure that you need for any web page. You don't have to keep writing that infrastructure over and over again. So a lot of the code that you had to write so often for ASP, you don't need to write at all because it's just built into the page that you run. Another nice feature is that when you need to replace a component of your ASP.NET application, you can do that without bringing down IIS. You just copy over the new page, DLL, whatever the component is, and ASP.NET takes care of servicing existing calls to that component with the old component and new calls to the new component. It's seamless, it's invisible, and you don't need to do anything to get that functionality. And it does this because it allows multiple versions of assemblies, multiple versions of the same assembly to exist on the server at the same time. Very, very nice features. ASP.NET also has a very clean separation of code from HTML. What this means is that you can have a designer design a web page using HTML and other components such as Flash or whatever, and the programmers can write the code separately from that HTML. The elements can be stored separately, so you have a very clean separation of duties. So it's much easier to collaborate on ASP.NET pages. Visual Studio provides a very rich development environment that has a number of tools that you can use to develop web pages. You can do things like drag and drop controls, set properties. You have full IntelliSense as you write code, as well as when you write HTML and JavaScript. And the Visual Studio environment is also programmable and extensible, so that there's a lot of third-party tools that you can get to enhance the environment, or you can write your own. And Microsoft continues to expand the opportunities for that extension. ASP.NET features cluster-friendly state management. You no longer have to store session state within the session object on a single machine. You can store it in memory in other machines or in SQL Server, or if none of the options within ASP.NET work for you, you can create your own state management engine. So this supports web farms and web gardens, as well as load balancing within server farms, and it even allows your session state data to survive a crash of the server that created it. Very, very robust features for scalable web development. ASP.NET, and in fact the entire .NET framework and CLR, uses XML-based configuration files. So these are just stored as text files that are easy to update, easy to change, either by directly changing the text file or by using various graphical tools to change the settings. These are also very easy to copy to new servers, which makes it easy to replicate configuration to different servers in a web farm or even to different applications. ASP.NET automatically handles postbacks, which means that if you post back to the same page, ASP.NET has the infrastructure in order to handle that code. You don't have to write all that code to repopulate controls. In fact, postbacks are now the default behavior within ASP.NET. You actually have to do slightly more work when it is post to a different page. So you have all the tools you need in order to handle postbacks automatically. ASP.NET also automatically detects the type of browser that the user is accessing your website from and will configure the HTML that is generated at runtime for the capabilities of that browser. It's not a complete solution. There are older versions of browsers that it doesn't quite work well, and it doesn't solve all of the problems of cross-browser application support, but it does a very nice job of easing the burden. And quite frankly, ASP.NET development is just plain fun. A lot of web developers shied away from web development because some of the earlier tools and technologies, including ASP, just made things so darn hard. But now, ASP.NET and Visual Studio and the .NET Framework make it really a joy to code again. ASP.NET and Visual Studio don't eliminate the need for you to learn all of the different web development technologies. You're still going to need to know at least a basic knowledge of HTML and XML and cascading style sheets, in addition to whatever programming language you use. But the tools make it much easier to develop rich applications that use those different technologies. Every so often, you're still going to have to get down and dirty with XML and HTML and the other technologies. But with the modern tools, you'll find that you just don't need to do that nearly as often. Let's start talking about ASP.NET web applications. ASP.NET is not just a new and improved ASP. Microsoft didn't build upon ASP. Instead, what they did is they started from ground zero and developed ASP.NET as a completely new development technology. And what it provides is a brand new architecture as well. The bad news is that if you're a web developer and you've used ASP or PHP or any other web technology, you're really going to have to learn the new architecture from scratch. And a good way to do that is to build a new ASP.NET web application within Visual Studio. So that's what we're going to do now. So in this course, we use Visual Studio extensively. Every so often, we'll drop down into the raw text file to do something to demonstrate a particular technology, but for the most part, we're going to use Visual Studio. But Visual Studio is not required to build ASP.NET applications. Quite frankly, you can continue to use Notepad or any other text editor in order to create these applications. There's really nothing magic that Visual Studio is doing. It's just a graphical interface that automates a lot of the grunt work of creating these applications. But ultimately what you're doing is you're just editing text files. But as a practical matter, once you've started using Visual Studio, you probably really are not going to want to go back to Notepad, just because Visual Studio will make you so much more productive. And all ASP.NET features are available for all languages. You can use some 20 or 30 different .NET languages. The built-in languages are C# and Visual Basic, but you can use any supported .NET language to develop web applications using ASP.NET. So let's take a look at creating a new application using Visual Studio. I already have Visual Studio running. So what I'm going to do is go over into File, New, and select to create a new website. Now, as you'll see throughout the course, there are a number of different options for creating web applications. But in this case, I'm going to create a file-based website, one of the easiest types of applications to create. So that loads the new website dialog box. I'm going to leave the file system selected, as well as my language of choice. And I'll also put it in some convenient location. Notice that I create a default.aspx page. That's what we typically call a web form. So the default.aspx is a web form. It's the application that provides the visual page that the user is going to see when they download this page to the browser. I'll go over and click in the Design view, which gives a graphical interface to the design of the page. Next thing I'm going to do is I'm going to go to the View menu and open up the toolbox. This provides a list of the controls that are available for ASP.NET pages. I don't want that to show all the time, so I'm going to auto-hide that. We'll be able to get to that as we need it to add controls to the form. In this particular page, I'm going to create an invisible table to lay out the page. Visual Studio has direct support for tables, so I'm going to insert a table here, and it gives me the Insert Table dialog box. I want 3 rows and a single column, and then otherwise accept all of the other defaults. But there's a lot of different options on this dialog box that can format the table. So now I have a table within my web page. And the next thing I'm going to do is add some controls to each of the cells within this table. So I'll drag a text box to the first cell, a button to the second, and a label to the third. I can resize controls as I need to. For example, I can make the button control approximately as large as the text box above it. Visual Studio also has a lot of support for navigating complex websites. For example, there's this navigation bar here at the bottom that I can use to select, in this case, the table. And notice that now in the designer, the entire table is selected. And I can navigate around the structure of this web page, making it very easy to get to different portions of the page. I can also resize controls, such as the table, and notice that as I increase the size of it, it automatically increases the sizes of the different rows proportionately. So there's a lot of support for doing graphical design within a web application. Now I'll go back over to the Source tab, and you can see all of the selected HTML within that table. So this is the HTML that the designer created as I was dragging and dropping controls into the page. And by the way, this is actually XHTML by default. So it's well formed, all of the HTML elements are lowercase, they all have closing tags, and so it's compliant with XHTML. I don't have to use the designer in order to add HTML. I can directly edit the source here as well. For example, by adding a heading element here. Notice that I get IntelliSense and Visual Studio completes the tag. I don't have to worry about adding the closing H3 tag. So now we've directly added some HTML to our form. Visual Studio takes care of keeping the two views in sync. So if I did something like double-click Name here and go back over to the Design view, notice that Name is selected within the Design view as well. This is a really nice feature that helps you keep your place as you bounce back and forth between different views within the designer. I can also set various properties of this control. So I'll select the button control here, and I'll expand the properties window just a little bit. And I'll change the text property to say click here. Notice that over in the designer, the text automatically changes. It doesn't wait for runtime to change the appearance of that button. There's another interesting view within the designer called Split View. If you have the screen real estate, you can view both the design and the source view simultaneously. And as you select different elements in one window, the other window stays in sync. So now I'll select the label control, come over to the text and delete the text there. And notice that it makes the change in both views simultaneously. Which view you make changes in is personal preference. A lot of people prefer the graphic view of the design. A lot of people prefer to edit the HTML code directly. With Visual Studio, you have the choice. Either one works just fine. So let's go back to Design View for the moment. The next thing I'm going to do is add some code behind the button. So I'll come over to the button, double-click on it, and Visual Studio opens the code behind file. And in this case, when the user clicks the button, I'm going to update the contents of the label control to greet the user. Notice that I have full IntelliSense. It knows that there is a Label 1 control there, so I can select the Label 1, hit dot, and then start typing in text, and then I'll press the Tab key to accept the text property. In this case, I'm using the format method of the string object in order to provide a standard string that will replace that 0 in brackets with the contents of the text box 1. All right, at this point I've made a number of changes. It's always good to save early and save often. So that's my page. I'll come back over into Solution Explorer and right-click on the default page and select View in Browser. This is going to run the page within Internet Explorer so that we can test the fully functional version of the page. I'll come over here and type in Don, click on the button, and the label displays Hello Don. So we have a full page that consists of HTML, some C# code behind it that responds and dynamically updates the page when it posts back to itself, displaying the additional text on the page.